Hi, Michelle. I'm just Lane. How are you? Okay, good. Well, I hope you did okay on NCL. Okay, so sorry about the late post. It's just so crazy lately. Like it just gets worse. So, but yeah, I keep trying to get stuff online and get interrupted with things. But we are gonna cover Unit 10 today. Um, pretty much light. I think if you watch the tutorial video for on LinkedIn Learning, you already got the general idea for threading. So we're gonna go over threading today. And then we're going to work on a lab. I will get the project information up. I think this time I'm going to narrow down to a few areas. And I would have flexibility for you to choose, or if you want to come up with your own project, you can, as long as you are fulfilling the criteria that all the topics we went over so far, with parallel programming, concurrency, and also we are going to reach another area where we're going to talk about pattern. So after this, it's going to go into pattern, and then starvation and deadlock. I think it introduces in this one, but expand on it further. So if we, oh, good to know that you're doing better this season on NCL. Every season should get better, right? So let's take a look at your notes and your assignment. Let me get my thing open and then I'll share screen. It's raining. All right, so you will find this in Unit 10 notes. In this particular chapter, we're actually going to cover 2 chapters. S11 is fairly short. It's supposed to be an extension of 10. There are only 2 examples in the text that covers in 11 talking about with statement. So I want to couple them together. As you know, that the book has like 20 something chapters. So if we just cover 1 chapter per week, we're not going to hit all the areas for the content for this course. So I wanted to kind of amp up a little bit. There's some chapter that we're going to have to double up, but in general, you know, they're pretty short. So so in this week, we're going to talk about thread, and as I mentioned, if you watch the tutorial video, you probably learn a little bit more about thread in the tutorial video. And so thread is just the smallest unit of commands or code that the OS can use to process or execute a certain task. So in a process, you might have multiple threads. To start, originally we have one thread per process, but later on we're able to implement multiple threads per process. So you can have more than one thread in a process, and you can have them execute concurrently. And the benefit of using a thread compared to a process is we're able to share the same memory location, or we are able to share resources. So, and they are also allowed to share instructions or code and context, or what we would know as values and variables at any given time. So data and memory are being shared, right? And data can come from the same location and instructions can come from the same location. So that's the benefit of thread, is that it is sufficient in the storage. And so now if we're looking at individual thread, they can be treated as independent component in a process, even though they're sharing the same location for data and instructions. So there are several ways that we would implement multi-threading. You can do sequential processing, in which you can have a single command that's going to be executing, or you can have more than one thread exist and execute in a single process simultaneously. Now, if we're looking at a processor that only have one core, what we can do is we can implement multiple thread by a technique called time slicing, in that it's just switch back and forth. So the switch just happens very fast. So it looks like the execution is being done in parallel, but it's actually sequential. So in the example or the illustration that's shown on page 1, you can see that the task is using time slice, like for task 1. And so it's gonna base on the priority. So in comparison from task 1, 2, and 3 to task 4, task 1 is then being time sliced. And so it's gonna complete task 4 first, because that's a higher priority. And it's gonna switch to task 1 and then task 2 and then task 3 and so on. So the switch happens fast. So that way, to the user, it's going to look like it's simultaneously executing, but it's actually sequentially executing the thread. So that's for a single processor. But when we look at multiple processor, you can have each core handle each thread simultaneously. And in such case, if we're looking at individual core, we can still implement time slice to switch between the tasks in the multiple core environment, but it's not recommended. So what they're saying is that you should have each core handle each task in the case where you have multiple cores. And in the case where you have a single core processor, you would use time slicing. So now I'm going to switch back to the assignments. Let's take care of some of the questions. So we have identified what the thread is, right? And comparing a thread to a process, your book spent a section on this, but a thread is an element of a process to really describe number 1. So that's the main difference, is that a process would be a composite of either one or multiple threads, right? And you can have more than one thread in a process, and you can have them execute concurrently by allowing sharing or accessing the same resources such as memory. And threads can share instructions and data, in that going back to the second bullet, we mentioned that it would come from the same area of memory. Unlike what we talked about in parallel processing, we were talking about how we want to stay away from sharing the memory for multiple processes. So in threads, we're able to do that. We want to share the resources, and that will give you sufficient management of your resources. And thread is independent component that is similar to a process, but within threads, threads within a process can share address space and data, unlike process where it doesn't share address space and data. Right? Last week, we talked about how that can create conflict when you're updating the data for one process and it's impacting another. So slightly different than the process in that sense. Any question for number 1? Okay. So for 2, it asks you what is multi-threading? How is multi-threading different than from single threading? So in a single threading, in the text and also your notes mentioned that this is sequential processing. It's going to execute a single command at a time. In multi-threading, you can implement more than one thread, and it can execute a single process simultaneously. And we touch on how we would use multiple core versus a single core. And in a single core, we time slice. Okay, so make sure for final exam, we know the difference between thread and process. We also should understand what is multi-threading and the difference between multi-threading and single threading. Okay, so that's going to lead us into the third question, which we touched on, which is time slice. And it asks you, how is time slicing used in multi-threading? So it is a technique that allows the CPU to switch between different software running on different threads. So if you're looking at your applications, right, we're able to use multi-threading in the sense where you can have multiple apps running at once. And what that will do is your processor would switch from one task to another task across these applications. And so in time slicing, the CPU switches its execution quickly, and it would create a perception of parallel execution. So technically, it's only doing one command at a time, but because we're able to use multiple core, right? And so each core is going to handle each thread. So you're able to have multi-thread execute simultaneously. Now, in the case of a single core, you time slice, all that is going to switch back and forth based on the priority of the task. So when you're looking at an application like antivirus, right, some tasks have higher priority than others, like, for example, scanning compared to updating virus definitions. Time slicing the same as concurrency, but coded differently? No. Okay, so when you time slice, it's similar to what you're using with concurrency, but you are going to, so when we're working with parallel processing, you create a pool of workers and you would assign each worker for each task. So it's going to execute one function per process, right? In the time slicing, what you would do is you would create a list of tasks, and it's still going to go through each of the tasks, but you also going to queue or bring in certain tasks. So that way it would set up and it's going to weight the priority. So the ones that are in queue that have priority is going to get executed first. So if we're looking at the example from the notes, right, if you're looking here, so all of these are, let's say, on the list. So we have task 1, task 2, task 3, and task 4. Since task 4 has the highest priority, it's going to execute that one. And so it's going to slice between task 1 and task 4. Then it's going to queue T1, which is task 1. And then it's going to jump to task 1 for the instructions. And then subsequently task 2 and task 3. So you're still using sequential in a single core, but what it's going to do is going to manage what's being seem like concurrent, where it's going to load and wait. Okay. And so what we have is that the time difference between switching the task is so minute that we won't see the difference from a user perspective, but from the system perspective, when it's sliced, so instead of completing task 1, it's going to jump to task 4, and then it's going to come back to task 1. So in such that it's going to be very small in difference that you see, you feel like it's going to do task 1 and task 4 at the same time, but it's not. It's executing the command from task 4 first, and then task 1. Okay. So coming back here, right, as we talked about how time slice can be used for threading. And so in the case of a single processor, we would implement time slicing for a single core. Okay. In a multiple core, we can implement it, but it's recommended that you allocate 1 thread per core. So for simultaneous execution. So then that would answer number 4. Describe how multi-threading is implemented using multiple core processor. So each core can execute each thread simultaneously. Separate threads in the same program can be executed concurrently or parallel if they're sufficiently independent. So we would treat them as independent threads, even though they're sharing the same memory location. Yes, that's correct. So in the case where if we have multiple threads, then it would be handled, each thread would be handled by each core. And even if your data is coming from the same memory location or the address, it would also be treated as independent. Okay. Any question? So now, what we see is that with multi-threading, you would have advantages and disadvantages, right? Just like everything else, in the implementation of multi-threading, we got to take a look at what outweighs the other. So the advantages would be that we know that we can make it faster, okay, and more responsive using multi-threading. We can also allocate resource better in that we are able to share from one memory location or the same memory location. But there are also disadvantages in multi-threading. Okay. So in the case of advantages and disadvantages, you would see that on page 2, after it talks about time slicing. So we mentioned that it would execute faster. And because separate threads in the same program can be executed concurrently, we can also have it respond better. So it will be able to take different user inputs simultaneously on separate threads. And if you're looking at applications, right, each application, even on the same application, you have multiple threads. So in that process, what we can see is that the inputs can be different, but can be executed simultaneously. And then we mentioned that it would be efficient in that it utilized less resources, and it's going to lead to quicker communication across the threads. But the disadvantages on page 2, it says that sometimes when you come across illegal operations, and if you don't manage the illegal operation, it can impact the process in which it crashed the program. And you also need to manage synchronization, so that way threads can be coordinated and systematically utilizing or computing the data. Because if data are changed or manipulated, right, it becomes a problem where if we don't manage the thread, that will lead to something like errors in that we don't manage deadlocks, live lock, and race condition. Okay. So these topics are going to come up in the next few weeks, where we're going to focus a little bit more, but in this week, we're going to focus on locks. That comes later in this chapter. So for the next question, the disadvantages, you will find this on page 2. Okay, so we can say that the disadvantages for multi-threading would be that it could crash, and that's from illegal operation within the thread, which impact the process. And the second area would be synchronization. You need to coordinate the threads, so that way all the data computed and manipulated correctly. Otherwise, right, it would create things like deadlocks, live locks, and rate condition. So those are the 2 things that we want to be mindful of when we're working with threads, right? Even though there are benefits. Any question? And in Python, we have the threading module, in which we can utilize some of the methods to be able to create threads and start and join, similarly to what you've seen with process. Now, later on, the authors, they implemented what's called a queue to be able to manage a pool of threads, so that way you can utilize very similar to what you've seen with workers. So what we would have is we would have a pool of threads, and we would be able to manage each of the thread in the program. So let's take a look at some example. Okay, so the textbook provided some example for chapter 10 and 11. And the way that they did it was that they create a module called my thread. Okay, and this particular module is going to import threading, and it's going to import time. So as threading has a superclass, which is thread class, what you need to do is you need to create a subclass that's going to be utilizing the methods from the module, the Python module. Okay, so here when we define a class, myThread, all that is it's going to be a child class that's utilizing the thread superclass from the Python module threading. So we instantiated, right, these members, name and delay. And then within this class, we also define a member function or method. And simply what we're going to do is we're going to print, right, starting and finishing. But this line right here, thread countdown, that's going to initialize the actual thread. Okay. Now, outside of this class, we have a regular method where we have it and where it's called here. Okay. So we're using the function run to call thread countdown, and basically it's going to count down the number of threads that's executed. And then we have a while loop. So in this while loop, right, we implement delay, because remember we still have to, in concurrency, we have to make it sleep. And so that way we would be able to make it go into a wait time and then execute. So then we would count down and we increment down each one by each loop. Okay, so this is the module. And what we can do is we can have a program, a Python script that's going to use the myThread module. So in example 1, we're going to import in the module, which is myThread, and we define 2 objects, thread 1 and thread 2. And these objects it's going to be utilizing, right, the attributes from myThread, which is here. And what attribute am I talking about? The member methods and the variables, right? So here, then in the argument, right, we're going to pass A and B, and then the time, 0.5 seconds. So the start and the join here actually comes from threading module. So what you would do is you would use the object and you would start and you would join the thread, and then you print finish. Now I'm able to run this on the interpreter, but as you can see, it's not truly a concurrent program, as interpreter is going to run it sequential. One would raise an exception for illegal operations, yes. Because that way you would handle the exception in the case that it occurs. And if it's true, then it's going to be handled. Otherwise, it will halt your program. Okay, so I think you're looking at the future example there. Okay, so when we run this, I don't know if you can see this, right? So what it's telling me is going to start thread A. It's going to plug A in as we pass A as an argument here and B as an argument here. And it's going to use this module. So here at this point, it's going to execute the run, right? Even though we run the example 1, so it's going to run this file, and then it's going to count. So it's going to enter the loop here. Okay. And we're going to increment down. So 5, 4, 3, 2, 1. So thread B is going to count 5, A5, B4, A4, and so on. Then when it finished, it's going to finish thread B. and then A, and then it's going to tell me that it's finished. So at that point, right? So when it enters the loop, we would see the counter with the while loop here. That's this part. Okay. Then when we finish, it's going to be here. So we finish thread B and then thread A. And then we're going to come back here and it's going to finally print finish. So when it starts, what it's going to do is going to activate the run function here from the module. Okay, and then app for A and B. And then it's going to loop. And so that means it's going to run this function. So as we tell it to join, it's going to wait for B to finish, and then A is going to then finish. Okay. Similar to what we talked about concurrency with processes in the past. So you would see these methods being implemented once again, but this comes from the threading module. Okay. Now, so as you can see that we would be able to write, right? So it's recommended that you would start with object class as thread is the superclass. So you would write the subclass for it. And then you would create the object to utilize, right, the member functions within that subclass. Okay. So when you're using threading module, the functions, hold on, let's go back to the notes real quick. So the example that's provided here, we looked at those, I screenshot that for you. Okay, and it talks about how the functions are used. Okay, you can also refer to threading package documentation on what is start and what is join, but the book does talk about it. Okay. So when you're using the start method, it's going to invoke the run method. Okay. Now, later on, you're going to see that if you're using the is alive method, it's going to check to see if that thread is still alive. And it would be considered alive if the activity has started. If it stops being alive when the run method is terminated. So when run ends, that thread is considered no longer alive. So that would return false if we wanted to check if it is alive. If you're using the join method, then this is gonna, the threads is gonna call the threads join method. This is gonna call the thread until the thread whose join method is called is terminated. So with A and B, we want to join after it starts. And then we can use is name to look at the attribute. Okay. So we'll come back to the example for the prime numbers. So in the threading module, when you're looking at the threading module, which is different than thread module, right? So the threading module, these are some of the primary methods that can be used, or functions. So you can have active count, which returns the number of currently active thread objects in the program. Current thread is going to be the number of thread objects that's current thread control from the caller. And enumerate is going to be the list of all the concurrently active thread in the program. So in the next question, it asks you, when using threading module, which function returns the number of currently active thread objects in the program? And which function returns a list of all the currently active thread objects in the program? So the active count is going to give you the active thread objects. Okay. And then the enumerate is going to give you a list of all the current active thread objects. Okay. So the second one, the enumerate, gives you the list, compared to the first function, active count. It's going to give you the count, the value that's counted for the active thread objects. And as we need to manage the threads, those functions can be useful. Okay. And for number 6, you can refer to page 5 in the notes. Any question? Okay. So now let's practice writing a class. But before we do that, let's take a look at another example. Okay. So in example 2 of the text, you're also using the same module, and this is why we would write a module. We can use it for multiple programs. And in example 2, this is a program that we would determine if a number is a prime number or not. Okay. So in this program, it's pretty straightforward. We have a function that would check for prime number, right? If x is less than 2, then we would print that it's not a prime number. If it is equal to 2, we would say that it is a prime number. And if it's mod 2, then it's not a prime number. And then we have, these are the conditions. So in the else, we have a variable called limit. And we would take the square root of x and we're going to add it by 1. Then we can implement the for loop or for range. And that's going to use limit 3 and 2. So in here, what we're going to do is we're going to do x mod I is 0. Then we want to say that it's not a prime number. So our input comes from a list, a 2, 193, 223, and so on. These are the values we want to check to see if it's a prime number or not. Now, in the second for loop here, we are going to run, right? We're going to start the thread by using thread start. I'm sorry. Yeah, by using thread start new thread. And we're going to use the input. So at the end, right, if it doesn't exit, you can just stop it by just press anything. And it's going to print finish. So when we run this program, right, it's going to tell me that first, type anything to quit, because that's here. And 323, which is this right here, is not a prime number. Then 193 is a prime number. And then 4337 and so on, that's a prime number. So it went through and it checks these conditions for each of the value for the input. And then 1327, that's a prime number, and 2 is a prime number. And you notice that they're not sequentially handled as what you would see in as a list, as a container. It's going to go here, check that one first, and then go here, and then here. So when you use this method, it's going to create a new thread, and that's how you would start a new thread. And you are using thread as a class. Okay. So now if we improve this program, if we add in the subclass my thread, like what we've seen in the other program, then we simply import threading. In the class, we would then instantiated X. And we would define a member function and to use the value X to check if it's a prime number. So pretty much still the same function that we've seen previously, but now we're adding a class. And we still can start the thread, but here in this case, we would then create an object called temp thread. And temp thread is an object of my thread, which comes from the my thread module. And it's going to start. And everything when it checks, it's going to append that to a temp thread container, or sorry, an object. And then since we're implementing threading, right, we wanted to join, because we started it here, we need to join that here. Okay. So if we run this, we're still going to achieve the same thing. Okay. But in that, it's going to also start at 323, and then it's going to go for, it's going to jump over to this one, check this one, and then it's going to come back to the first two. Okay, so now we saw some example of how to write the class. We're going to go ahead and practice. So for number 7, we are going to create a new thread using threading module. We're going to define a class called new thread, and it's going to implement the threading module and instantiate two members, var1 and var2. Okay. So first, you would say that it is the class and give it the name. So the name that we want to use is new thread. And since it is a subclass of thread, you would then use threading and thread. Okay. Thread is the class from threading. So again, you know, right above that, we would have to say import threading, and then we would define the class, right? And then under that, we would have init, and we would say self, var1 and var2. Since this is a subclass of thread, so we would say threading.thread and then in itself. Then our variable, our members are going to be self.var1 is going to be called var1. Self.var2 is going to be var2. And that's how you instantiate the the variables, or the members, I should say. And then subsequently, we can follow up with a function or a method definitions to do something with these variables, right? With these members. So that allows you to be able to expand on the program after that. Any question? Okay, so you can definitely find the example. Let me see. In the notes, but also in threading, if you take a look at the documentation, right, it goes over on specific. You notice that it uses threading and then dot whatever methods that you want to use here. So it gives you a list of different methods like enumerate, main thread, set trace, and so on. There are lots. Okay. So in the middle sections, it talks about how the thread class represent an activity that's run in a separate thread of control. So you can use it two ways: by passing a callable object to constructor, or by overriding run method in a subclass. So when you create a subclass, what you can do is you can override the run methods by using the start method. That's what we've been doing. So once you create the object, you can use that object to start, okay, which invokes the run method. So when do we see that? Here is where you would have, so here's your object right here, right? And then you would do a dot start. And then later on you can see, and also in the first example, this is your first object, thread 1, and thread 2, second object, and then we would say thread 1 start, and then thread 2 start. Okay, and that's how it's going to be able to run the thread for the first thread and the second thread. So in the next section in the documentation, it says other threads can call the thread's join method. This blocks calling the thread until the thread whose join method is called terminated. Okay. So this is also important to note. That's why we would have the join method following start. Okay. So for question 8, it asks you, using the threading module, identify the methods that are associated with the below operations. A, returns the name of the calling thread. We would use the getName method. So in the text, it gives you the commonly used method in the threading module, right? GetName or setName. So getName gives you the name of the calling thread. B, begins the initialized calling thread object by calling the run method. So instead of using the run method, you can initialize the calling thread using start method. Then C, waits for the calling thread object to terminate before continuing to execute the rest of the program that will be join. So it's gonna wait for the calling thread to finish before it's gonna execute the rest that will be joined. And then lastly, D, this method run is executed when a new thread is initialized and started. So run. So when you use start, it's going to invoke run, but run itself is a way that we can execute a new thread that's initialized. Question. Okay, so make sure that we're familiar with how these methods are used in a program for multi-threading, right? The methods, what the each of the operation would be. Okay, so you can find the threading module methods that support thread class on also page 5, following the methods that we talked about using to count threads and enumerate. I also provide the link for the main documentation. So to create a new thread, what do you need? You need to first define a subclass of the threading.thread, like what we practice. We want to have a method inside the subclass, which is an init method, in order to add custom arguments to that class. We also want to override the run method inside the class in order to customize the behavior of the thread in the class. So those are the 3 steps that we need. And so therefore, right, we should practice writing the subclass when we're implementing the thread, because it's using thread superclass Okay. So now after you have created a thread, you need to learn how to synchronize your threads. So synchronization is a way that we can have, right, one concurrent process or thread execute a critical section of the program. So on the top of page 6, it says that when a thread is accessing and executing a critical section of the program, the other threads must wait until that thread is finished execution. So when one thread is executing that critical condition, the rest just waits. Okay. So in the thread or the process synchronization, that's what's going to happen. The goal of the synchronization is to avoid discrepancy in your data, in that multiple threads are accessing the same resource location. So if you put data in the same area in that memory location, if you have multiple threads accessing that data, that can cause discrepancy, or your data would be manipulated across those threads. So therefore, we would synchronize the thread in that only one thread can access the critical section of the program at a time, and the rest must wait. So that will give us the next answer to number 9. What happens when a thread is executing a critical section of the program? And this is part of synchronization. All the other threads must wait until the thread that's executing is finished. And why is that important? Because that's the primary goal of the thread synchronization, is to avoid the potential data discrepancy when multiple threads accessing their shared resources. Because we want to have accurate data. We don't want manipulation in the data where we would have discrepancy across multiple threads. Question. Okay. So now, and again, you can find the answer there on top of page 6 and the end of page 5. So then it talks about thread.lock class. And the common ways to apply synchronization for thread is to implement locking mechanism. So when you're using threading module, there is a class called threading.lock. And it has built-in methods such as the threading.lock method, which initialize and return a new lock object, or you can use acquire blocking. This allows all threads to run synchronously, and you have to implement the blocking arguments. Okay, so when you block is 0, it does not wait for the lock. When blocking is 1, it waits for the lock to be released. And then when you're using locking mechanism, you also need to release. So when you use release method, that simply release the lock. Okay, so the complete example of this is, yeah, so here it implements an object thread lock, right? This is a locking object. Okay. And with that, we can set up our lock. So in the run definition, or the run function definition, here we would set the lock and then release the lock. Okay, so that's one example. I think there's another one. Let me see. CQ. Yeah, your text shows only that one. Okay. So to look closely to the acquire blocking, right? So these are the methods that's built with the threading.lock class. If you use acquire blocking, all threads will run synchronously. That only one thread is executed in the critical condition, like what we talked about before. So that way, all the other ones must wait. And this, the argument allows you to specify whether the current thread should wait or the acquire lock. So 0 means that it doesn't wait, and 1 means that it waits. Okay, off and on. So for the next question, it asks you, what happens when the acquire blocking method is called? That it allows all threads to run synchronously. One thread can execute critical section each time or at a time. And when you use the value in the argument, that's going to tell the CPU whether it's going to wait or not wait. Question. Even though as a combined two chapters, if you look through the text, it's fairly short. A big chunk of it goes to the example and the explanation of the example. Okay, concept is fairly short otherwise. So here I added the screen capture for the example of using threading.lock. Okay, and all you have to do is import threading, and threading.lock is part of that module. Okay, so how do we set the priority for the multi-thread? Earlier you saw the diagram saying that, oh, well, task 4 takes priority. Is this the VHX? No. So now, if you're familiar with C and C++, you're probably familiar with Q and DEC, right? I know in CIS30E, I talk about DEC, but in this case, we're just using a data structure to be able to manage threads and basically manage the priority of our threads. And so you can add in elements into this abstract data structure or the container called Q. And the elements would then be added at the end. That's going to be the NQ. Now, the elements can also be removed from the beginning. Take out the front. That's going to be called DEC or DQ. Okay. So the way that the queue works is we can have it first in, first out. So if you put it there first, it's going to be in the front, and that's going to get removed first. That is different than what we normally see as a stack, where it's going to be last in, first out. So in a stack, whatever's get added last, that's going to be the one that pop out first, right? So here, what we would see is that all the elements in the case where we remove everything and there's nothing else to be removed, it's gonna be shrink down to no element, and therefore that will be empty. Now, in the case that it reached the maximum capacity of the queue is going to be the total number of elements that it would contain. So Python has a module called queue, and it uses queue.queue class. That's the superclass. And again, you also have some of the methods that was implemented for that module, such as get, put, queue size, empty, and full. These are only a few. But if you look at the documentation, you would find that there are additional. And there is a method called priority queue. Okay. So what you can do is you can create, similar to the example here, a subclass that's going to set up the priority of the element which represents your threads. So the way that we can implement the queue is that it becomes a data structure in that it would hold a pool of threads. Which doesn't really hold any information about the task, but you would store the task in the queue. So the thread itself doesn't hold the instruction for the task, but the queue hold the instruction for the task, which is called task queue. So then the queue would then fed to individual members of the thread pool. If the task queue is then containing elements that will be processed, then the next element of the queue will be sent to the thread so that it became available. So it's going to basically associate each of the thread to the element in the queue for execution. So the illustration, the text provided is like this. So you have a thread pool, and then you would have a queue for the task. So it's then gonna link what's in queue for that particular task. And then as it would complete the task, right, it's gonna be able to tie the element with the task at queue. And again, a queue is just an abstract level or an abstract data structure. So the example that we can use queue with threads would be this. So here we would import in the libraries. We already saw how to create the subclass, but we stopped here when we did the questions. As you notice that when we implement the queue, we would use process queue here. And then we can check with the exception, try and accept. Now we would get the block false is going to be 0, right? So we would get block for false, and except for then when it's empty. So when this checked true, it's going to return. And so when you fill the queue similar to other container, you have to implement a for loop. So here we create an object called myQ, and the object is, it's an object class of q.q. And here we would be able to add the element into the queue, which is X. And so after that, we would initializing 3 threads. And we would start and join those threads. So when we run this, so here you start class thread A, right? And so it's going to start the thread. And then for the print factors, it's going to print positive factors of 1 is 1. Then starting thread B, that's the second thread. Factors of 10 is going to be 1, 2, 5, and 10. And then C, starting thread C, positive factor is 1, 2, and 4. And so on. So when it exits, it's going to exit thread C and then thread A after it did thread B. So that's an example that you can look at that's provided here on page 9. And if you have the book, you can also download the code. I think it's available on GitHub as well. Okay. So for number 12, we can define what a queue would be and how it's implemented in the concurrent programming. So a queue is an abstract data structure that is a collection of different elements maintained in specific order. First in, first out is the approach for queue. And when you add to the end of the queue, we call it the end queue, right? So the way that we can implement the queue is that it can be used as a structure containing a pool of thread that represents task queues, and the items in the queue will be fed to individual members of the thread pool. Question. So as we finish the queue section, that will be the end of chapter 10, and then going into 11, it expanded on using the with statement in threading. Just a little bit more to go, and then we'll finish the session. Hang tight. So in chapter 11, it talks about using the with statement. And as some of you have seen this before, we've used with open, right, for file. So the way that the book represents this is their example program uses with statement as a context manager to manage resources, as in the task to open and write file or append file. So this statement, this type of statement would allow you to manage resources in concurrent and parallel programming, especially when we are sharing resources across multiple threads. So the example of a file, to open a file, would be like this. We would have an end file, initialize at 254, and then we have a list of that would be files. We have a for range, and we're gonna open the file and append to that file called sample i.txt. So here you notice that we can use method 1, method 2, and method 3. So in method 1, we're using a for range to append to the file. And in this, we don't have an object. We simply just loop through and add to the end files. And so as it does that, it's going to open and write. So it's going to store as it loops through. In method 2, in the for loop, we created an F object. We construct an F object here. And it's going to append to that object and then close. In the third approach, what we would do is we would use a with open statement. And this becomes a context manager. Very similar to what you've seen in method 2. The main difference is in that we don't simply just open. We don't define the F object that's just open and write to file. We would use the with open statement. So that way it would be managed, the operation for that. Okay, it still achieved the same thing across 3 approaches. But in method 3, we use the with statement. Okay, let me clear this. So as you run this, you would see that nothing is going to be output here, but we would create, right, sample i.txt. Now we can uncomment this or this and achieve the same thing. So provided here is the example for non-threading first, and then you can implement threading. So the way that we implement threading, we also need to implement lock, and we would then still be able to open and read and write files. Now, in the case where we want to have try and accept, in the case that we run into errors, so when we try to open a file and if it doesn't exist, if it hasn't created the file, then it's going to say file not be found. Okay, so here this shows you how you can also implement lock and release. And that will be in the second example. So we can simply append data, right? So if you read from the top, it's simply implementing the threading, and we're using the lock. We create a lock. And then here it would induce the deadlocks by using the acquire method. And in that, we would open the file. We're going to read from that file, then release the lock. In the second function, we're using the with statement. With my lock, open and read the file. We have a data list and we have try and accept. So in the case that it runs into error, right, it would notify us that the file's not there. And it's always good to handle the exception. If we expect that there might be an error, we want to handle the exception. And then we can still handle the deadlock. And then we just want to print to confirm that that's done. So this is to read. Okay. All right. So for 13, the statements that can be used as a context manager to manage resources, especially when you're working with parallel and concurrency programming, that will be your with statements. And so if you're looking at compound statement, going back to a little bit of 30A, I have a message. Is the lock here considered to be mute X? In this part right here? Yes. So for the next part, what we're going to do is we're going to look at, where was I? Compound statement. So if you look at Python documentation, when it goes over compound statement, it talks a little bit more about what a with statement would do. Okay. And in this section, it talks about with statement. This is used to wrap execution of a block with the methods defined by the context manager. You can commonly implement try, except, and finally usage with the with statement. Okay, so some of the examples that they provided here. So the execution for the with statement with one item preceding. You can do context for enter, exit, right? That will be loaded for later use, or you can have method invoked. Now, the book shows you the syntax for this, but you simply just use with and then your expression as target and then the suite. So the way that we see here, right? This is your expression with my lock open file, read attribute as F. That's your target. F becomes the target in that case, which is your object. Now that's different than what you've seen. So comparing this, right? Let's take a look at this method and then this method. The third method uses the with statement. And in that, we don't have to define the object F. We would simply use the with statement. We can say with open, right? Output file sample.txt. And then we would write as F. So this is your target F. And it's going to append to that target. in the second method, we actually define F, which is for open sample.txt and to write to it. And then we would append. And so you can see that they are different in that how we would approach using, in this program, we implement two methods, right, would achieve the same thing. Okay, so in the next one, we would, the last question, we would write the if statement. And it asks you to refer to the notes and example and write the with statement to open and write the file sample.txt. So we can say open, or I'm sorry, with open, and then our file name, sample.txt. And we want to have attribute write, so W. S, our target would be F. And you can identify it as anything. It could be F, it could be file, right? It could be B, A, X, etc. And since the question asks us, right, to open and write a file, if we want to append to that file, we need to follow this up, right, to write. So we would do data.append f.write. And we would pass f.write into the append method. Okay. And that's how we're able to write a with statement, which is a compound statement. And we would use it as a context manager and apply to, using it with lock and other context in parallel concurrent parallel processing or concurrent processing. You can write your with statement in that sense. Question. So 14 shows us how we can do that. You can always look back in your notes and your textbook. Okay, here it shows you how you can write your with statement there and how to use the syntax there. And I also included the same documentation that I showed you earlier on the webpage. Any question? Okay. So for Wednesday, we are going to do a few things for the lab. And I will be able to release and we'll talk about the project information on Wednesday going forward. Project is going to be due at the end of the semester, so you can start looking into how to do a project, right? And as you notice in the last quite a few labs, we mostly use Linux, even though you can use Tawny, but it's not going to give you the appropriate output. I only did this to quickly show you, but when you test these type of programs, especially threading, you want to use like Linux virtual machine to be able to test that. So for your project, just make sure that you have Linux virtual machine to test your program and then be able to write your program implementing all the concepts that we have discussed. The only area that we will, there are a couple other areas that we will address, and one of them is going to be pattern. So we will go over pattern in the next couple of weeks. And then we'll come back to starvation, deadlock, and race condition. to expand on those, and then that will wrap up our concept for the semester. Okay, any question? Okay, so there's no more question to answer. That's all we need to cover for today. If you're finished with everything, you can put your name into the chat for attendance and then submit your assignment, but it is due on Sunday. We will do the lab on Wednesday. And have a good night. I'll stick around a little bit for questions.